Assalamu alaikum dear students. Today we are going to discuss another application of derivatives, which is how to find the maxima and the minima of a function. So what is maxima and minima? Let f from interval I to R be a function defined on I, that is the domain of this function is interval, whether it is closed or open. Then f of this f is said to have maximum value in I if there exists a point c belongs to this interval such that f of c greater or equals to f of x for all x belongs to I. So here this f of c, that is it is a particular value, means it is a real number. This value is called as the maximum value of the function in interval I and is attained at point c. Similarly, f is said to have maximum value in I if there exists c belongs to I, that is f of c is less or equals to f of x for all x belongs to I. Here this f of x in this case is called the minimum value of this f in I attained at point x equals to c. So in general, if we can simply say that in both cases, that is f of c greater or equals to f of x, that is its maximum value, or f of c less or equals to f of x, which is the minimum value, this f of c is called as the extremum value of f, and c is the point at which the extremum value exists. Extremum value means simply the value which is either maximum or the minimum value. Like if we consider a function f from closed interval 1 to 2 to R, means it is a real valued function defined on closed interval 1 to defined by f of x equals to x square. Clearly it is continuous function, it is increasing function, and it is defined at the end points, means it is continuous at end points. This f of 1 is here 1 and f of 2 is 4. So at end points, at 1 the value is lowest because there does not exist any x in this interval at which the value of f is less than f of 1, or there does not exist any x in this interval I, that is 1 2, where f of x is greater than 4, that is f of 2. This means that f of 1, which is 1, is the minimum value of this function which is attained at x equals to 1, while as this f of 2 equals to 4 is the maximum value, because f of 2 is 4 is greater or equals to f of x for all x belongs to 1 2. So this means that 4 is the maximum value of f, and it exists at point x equals to 2 belongs to this I. Now if we consider the graph of the function, like this function, it is defined from -4 to 4. Clearly this at 4 or at -4, f of value is the highest, that is 4, because 4 is the highest value in the range of this function. F of 4 as well as f of -4 is 4, while as f of 0 is 0. There does not exist any x in this from -4 to 4 at which f of that x is negative, means f of that x is less than 0, or there does not exist any x belongs to -4 to 4 such that f of that x is greater than 4. This means that here 4 is the maximum value, while as 0 is the minimum value of this function. Now this minimum value of this function is attained at x equals to 0, while as this maximum value is attained either at 4 or -4. So clearly in both cases maximum value exists, while also the minimum value of these two functions exists. So from graphically we can find the maximum or the minimum value, or from the function we can also find the maximum value or the minimum value if it exists. Like if we consider the function f from 1 to 2 to R, means open interval, this means that function is not defined at point 1 and at point 2, because they are the endpoints. They are not included in this domain. Now here 1 2 does not belongs to domain, and clearly that this x square is increasing function in this interval, that is in 1 2 it is increasing function, it is continuous function, but it is not defined at the endpoint, at the endpoints of this, that is the domain is open. Now clearly the minimum value of this function, that is f of x equals to x square, exists at a point which is very close, which is closer to 0 from the right side, that is at the point which is slightly greater than this 1, at that point the minimum value exists. Similar, the maximum value is obtained at point which is smaller, just smaller than 2. But we cannot locate such points. That is, we cannot locate the point, although we can locate, but we cannot find, because there are infinitely many numbers between any two real numbers. Here we cannot find the number which is just greater than 1 or which is just smaller than 2. So this means that although this function is continuous, domain is here open, but we cannot find the maximum and the minimum value of this function, because if we assume that 1.1 is the point at this function, at this point the value is minimum, but we have 1.01 is also the number which is greater than this but which is less than 1.1. so there are infinitely many numbers, hence we cannot pick up one such number where the minimum value exists or the maximum value exists. So this means that simply we cannot this maximum and the minimum value of this function does not exist in this interval, open interval 1 2. Here this function is continuous and is more increasing function, but still this minimum and the maximum value does not exist, because the reason is that this domain is here close, this open. So from this we conclude that every continuous function, if we have a continuous function which is defined on closed interval, this means that domain should be closed, then maximum and minimum value exists at a point, at least one point in the domain. Or if we have the monotonic functions are those functions which are either monotonic increasing functions or decreasing functions. So this means that monotone functions are those which are either increasing functions or decreasing functions. That is why these functions, increasing and decreasing functions, are also called as monotonic increasing functions or monotonic decreasing functions. For these functions, which if the domain of these functions is closed, then the minimum and the maximum value exists. Here domain in this function, like if we consider this function, domain is open, it is continuous, so still this maximum and minimum value does not exists. Also it is increasing function, still minimum and maximum value does not exist because domain is not closed. And that is why we simply write for for continuous functions and for this non monotonic increasing functions, maximum or the minimum, that is extremum value, may exist or may not exist. But if their domain is closed, then it will exist, it must exist. Now this was about continuous and this monotonic increasing function. If we consider the functions which are neither increasing nor decreasing, neither increasing nor decreasing means those functions which changes behavior from increasing to decreasing, from decreasing to increasing. Like if we consider the graph of such functions, in the graph we have the points a, b, c, d and e. This point b is attained at x equals to 1. This means that f of x1 is b, f of x2 is here. Suppose this function is the graph of f. Suppose this graph is the function, this graph of f of x, then f of x1 is b, f of x2 is c, f of x3 is d and f of x4 is e. Clearly at these points, that is if we consider the point a to b, the portion of graph from a to b, it is increasing, because when we move towards right, the graph increases upwards, that is it is here increasing function. But from b to c, when we move towards in positive direction of a domain, the value of f of x gets decreasing. This means that here the graph is decreasing, it is the decreasing function. Here it is increasing, decreasing. So this means that at these points the function changes its behavior from increasing to decreasing, from decreasing to increasing. So these points where the graph changes behavior, these are called as the critical points, or simply turning points or stationary points. Now at b, c, d and e, this b, there is a hill type structure, while as c, there is a valley. So this means that it is downwarded, it is here upwarded, maximum value or the minimum value. So this means that maximum and the minimum value exists at these points, around these points, either at these points or around these points. So such very extremum value is called as the local extremum value, that is local maximum or local minimum. The point at which such exists is called as the local minima or local maxima. Like if we consider local, what is local maxima? If c is the in this point in the domain of function, then c is called a local minima. If f of c is greater or equals to f of x for all x belongs to the interval which contains point c, because c minus delta, where delta is the positive number greater than 0, and c plus delta is open interval containing this c. So in this, if for all x belongs to this interval, that is c minus delta and c plus delta, if f of c is greater or equals to f of x, then c is called as the local maxima and f of c is called as the local maximum value. Similarly, local minimum, if c is the local minima, if f of c is less or equals to f of x for all x belongs to this interval c minus delta to c plus delta. Here this c should be the interior point. Interior point simply means that point of a subset of a real number whose open interval is contained in that very set. Then that point is called simply as the interior point of this set. So this means that c should be the interior point. Hence at c we can define the local maximum or the local minimum, and the corresponding point where local maximum and local minimum exists is called as the local maxima or local minima. So inshallah in tomorrow's video lecture we will discuss how to find the local maxima and the local minima at a point. And for in this regard we have a test which is called as the first and second derivatives test. So thank you.